speaker that I'm echoing with. Okay. All right, everyone. My name is Dave Nielsen. I'm going to be the moderator for this panel today. However, I'm going to try to get the audience to participate as much as possible. If you know of me, you know that I run lots of cloud camps, and cloud camps are mostly unconference oriented, which means we'd like to get lots of interaction from the attendees. What are you guys doing way over there? Are you in a different session? Oh, you want power? Ah, I see. We all want power. I get that. Okay, cool. Well, you can stay over there, but I'm going to be talking to these folks over here. Okay. Anyway, so we've got a panel of 7 experience, well, including myself. Are we missing somebody? Did somebody leave? What's that? Okay. So we're okay, though? Okay. Well, we've got a panel of 6 plus 1 mystery guest somewhere who is here to answer your questions about getting started with a data mart, specifically a Hadoop Analytic Data Mart. How many of you have ever installed Hadoop or anything like it? Okay, that's a good half of the crowd, at least maybe 2/3. All right. I liked one of the questions from the previous session I was in. How many of you have installed Hadoop in less than 2 days? All right, so a few of you, not too many. All right. So part of the topic is obviously we want to create a data mart, but also we want to make it a little easier on ourselves. So hopefully we can get some of those questions and answers as well. Before we go any further, I'm going to let our esteemed panel introduce themselves. And since I think, are you guys all mic'd up?
I think so.
If you're not mic'd, okay, great. All right. If you don't have a mic, then hand somebody a mic. And we'll go ahead and start from the far left. I believe that's Antonio, right? Yeah. Go ahead and start. You can introduce yourselves. Keep it kind of short because there's a lot of us. Go ahead.
I'm a data scientist type. Right now, I'm a consultant working for Revolution and for Datasport.
My name is Doug. I've been at Google for about 10 years. So in that time, we've transitioned our technology stack where we first started out big data. We'd build things, but we'd also use things, and we would use it our big data infrastructure in conjunction with something like MySQL. And over time, our mantra has been scale out, reduce costs, and scale out more. And so we've gotten to a point where a lot of our things are custom, and they're built upon layers and layers and layers. Part of that philosophy is probably applicable to a lot of you guys. You guys are probably in different types of the technology curve. For instance, some of you may be on a SAS or Oracle installation, and the natural question comes up, when is it time to supplement with a NoSQL type of architecture? And then is there a time where, looking forward, that SQL products just completely go away? And that's kind of the path that we've gone through. We've actually gone through that roadmap.
Okay. Thank you.
Hi. My name is Jimmy Shanahan, and I consult in the Bay Area with a bunch of companies. Can you hear me okay?
Yeah, it's not. It's like, it's almost like we need to turn everything. What's the echo from?
This one?
Can you hear me now?
We can just...
Well, hold on. Let's just turn everything off and just use a mic. Okay?
Yeah, pass one mic.
Because this isn't working. Yeah. Let's turn everything off, and we'll leave one mic. Okay? Go ahead.
When you're walking.
Go ahead and talk loud. Just everyone turn off their stuff. I don't want to deal with this.
Can you hear me now?
No. Okay. Hello, hello, hello. Can you hear this one? Which one should we use? Because I don't want to go. Is this one working? Can you hear me, guys? Can you guys hear me okay?
That works.
All right, use this one. We're turning everything else off. Give it to me. Give me.
It's better. Okay, great. All right, so my name is Jimmy Shanahan, and I consult in the Bay Area with a bunch of companies, big companies, small companies, and they normally have lots of data, and they want to leverage that data to build intelligent decision-making systems. My role is generally come in, recommend what to do with the data, how to store it, warehouse it, then how to leverage it. My background is in machine learning, so I'm a big user of these types of tools. And I guess I'm all about the ease of use of these tools. And I also teach at UC Santa Cruz, and trying to teach students about Hadoop and trying to get them to do homework has been a pain in the ass for the last 4 years. And so finally, I think we've got to a stage where it's easy to install Hadoop and run jobs. And thanks a lot to Amazon. And also, one of my favorite tools is MR Job. It's been built in Python, released by Yelp, and it's a godsend really for teaching distributed algorithms and using MapReduce Hadoop type infrastructures. So MR Job, Mr. Job or MapReduce Job, and it's a great pedagogical tool, and it's something I recommend to my clients sometimes as well, if they want to get their head around distributed programming using MapReduce infrastructures. Okay.
This is working. Patrick Nicholas, I've been using Hadoop for 2.5 years. I'm from more the software engineering background. One of the purposes has been to build models so the prediction will be extremely fast in real time, and it's been I've been 3 projects really. One is advertising targeting by inferring demographics from user behavior and interest. The other one was generating content, and the third one, the current project at 24/7 content, consists of extracting ontology in real time and context in real time, which require generating model using Hadoop offline. I've been using a couple of non-SQL, and been playing with graph database recently, which is very good to model and store relationship between different entities.
What kind of graph, what's the name of the graph database?
I use Infinite Graph, and I use Neo4j. Okay. But it's been really experimenting. It's not in production, to be clear.
Hello, my name is Alex. I saw that many people use Hadoop. How many people use CDH? CDH? A couple of you, okay. I hope that number will increase, but Cloudera, basically where I work, is making this distribution available, easy to install, and I specifically work as solution architect, and I do exactly what the title says, helping people to build the first Hadoop Analytic Data Mart.
Hi, I'm Amir. I used to be at Yahoo's Hadoop team since 2006 for a few years. Last year, I left from Yahoo and working with another Fortune 500, probably Fortune 5 company, and helping startups as advisor to use whole stack of Hadoop, whether it's HBase, Pig, Hadoop, HDFS, or graph databases on top of that, etc., especially in the cloud on top of Amazon Web Services.
And our mystery panelist, Esteban.
Hey, Esteban Gutierrez. I'm customer operation engineer. I have to deal with dozens of clusters every day from customers around the world.
Okay, great. Okay, so now, if you have any questions that you might forget before you get a chance to ask them, you can go ahead and tweet them. How many of you have your phone with you, and you have SMS? How many of you? Raise your hand. Come on, raise your hands, raise your hand. The rest of you don't have your phone with you? What is wrong with you people? All right, well, if you can't SMS, maybe your phone has a data plan and you can download like the Twitter client. It's pretty easy to download. But anyway, if you want to tweet your question, you can. Just put the DM Camp hashtag, and we will see that. And it would help if you maybe put Data Mart as a hashtag as well. But if you just do DM Camp, we'll probably find it. DM Camp and Data Mart would be nice. Thank you. Okay, so to get started, I thought I'd ask a couple other sort of funny questions. So we found out that very few of you were able to install Hadoop or anything like that in less than 2 days. So obviously there's some challenges there. But before we even get any further on solving these challenges, I thought I'd ask the question, what is an analytics data mart? Okay, might as well start off with something easy. And Amir, I know you actually said I should ask this question, which I thought was right. So why don't you answer it, and we'll let the panelists try to answer it if they want to as well.
Okay, so we had two talks, kind of, in the previous session. The term data mart came back, which reminds me of data warehousing times a few years ago that Hadoop basically started. So to clarify, data mart has different meanings and definitions, but one is the part of a data warehouse, the whole ecosystem which has a particular topic and use. So if you have a subject, your subset of data means something, is used for a specific task, we can call it data mart. So Hadoop data mart is not an established term. So in this context, maybe we can put things in the context with this definition. Okay. If anybody else wants to comment on that part, so.
I think there is a little less motivation to split the data into specific data marts because of the scalability of Hadoop and other solutions, and also because we realize that discovery is important. If you design your data mart, you make certain splits a priori. This is marketing, this is HR, and you can't go into you're left without the possibility to cross those data sets. But now with Hadoop that scales horizontally, you just pull all your machines together, and and one director is marketing, the other is HR, and if you want to do a join between the two, you can. So I'd say, warehouse all the way, and data marts maybe a little less.
Okay. Yeah, actually, does this work too? Yes, okay, hold on a second. Now, I wanted to also set the stage I was just going to go to the next, well, add to this, please, because this session was initially proposed by someone who was interested in applying the answer to how do I set up a data mart to their job. Now, specifically to tie this all together, they, if you're using real-time systems, you might use something like Oracle, and you need something that's extremely highly performant, maybe some other highly performant NoSQL database or something. But for analytics of historical data from many sources, real-time might not be a requirement. And so they'd like to develop an analytical prototype of a smaller system for analytics purposes and have the option to scale it up to something that was more production. So, what kind of architecture can you put into place that might actually look more like a smaller data mart, but might be able to scale up to an entire warehouse type system? So that might be a place to start, because your point was well taken that when you can scale horizontally, you might not need a subset of data, but you got to start somewhere, right? So you want to build something that starts off maybe looking more like a data mart, but might end up being like your warehouse at some point. Did you want to add anything to that?
Yeah, actually, maybe data mart's not the best term for this. But because we have a data warehouse, we're doing risk analytics on fraud transactions. So last year we processed about 64 billion in transfers of transactions for consumers. But it's actually bigger than our data warehouse. But it's used by the risk analytics department to do the fraud detection. And we're actually pulling in from more sources than just the existing data warehouse team, which is for one kind of reporting. The risk analytics, we pull it in from fraud investigations and various other sources. So there's additional information that makes it larger. But it's when I said data mart, I was thinking more in terms of use for my department, doing risk analytics on a specific application, just like HR would be one application. But the data subset is larger. And we can go 3 years back, now 2 years back in the Oracle solution. We've recently been acquired by a bigger parent company, and we can get to 10 times more data that can be shared. And so now we have an opportunity to get much, much larger. And that's the attraction.
Great, okay. I'm seeing some tweets about this session, but no questions yet. So we'll continue on. Thank you very much. Now, the next question. Well, did anybody want to add to that, by the way? Oh, yes, okay. Well, you got to go ahead.
There is a very inexpensive way to start. If you have a in a growing database, you can dump the database or logs file into and use MapReduce to populate, for instance, star architectures with a fact base and different dimension using MySQL. You can go quite a bit of mileage from that. Or you can use create a partition and database using the MapReduce. This is very much what Hive is working also as a tool. So you can just use MapReduce to pre-populate a data warehouse. And it's fairly scalable. I mean, it's MySQL. So you can get something pretty inexpensively if it's not huge and without using NoSQL database. Okay. It's an approach.
I think that if you're starting out in the space, one easy way to get going is on Amazon's EC2 cloud. And shipping your data up to S3 is always a good thing to do. And from there, just firing up clusters on demand. There are wonderful services. We saw a great presentation from Alex and from Esteban just before this about the Cloudera system. And I guess for the Cloudera system, you can fire up a cluster of 50 computers for free, and then you start paying after that. 50 computers gives you lots of power. I think you want to do a lot of analysis and number crunching and all of that. And so one thing I find really useful is the S3, get your data up there. Then in terms of doing analytics, Hive is really a great way of providing SQL-like language to interact with your data, and that's a great way to start. And then if you want to start doing number crunching and maybe doing some modeling or time series analysis, MRJob is a fantastic way to get going very, very quickly, easily. And I think within a half an hour you can have a cluster fired up with the MRJob and be doing very simple analytics. And then if you want to go from there to machine learning and you want to say build a logistic regression model with 1 billion rows, well, hey, MRJob will do that for you. Of course, you can do it faster if you do it more in a native language like Java, but MRJob will get you there, I find, very easily. It's more of a development environment, but there are like open source packages, extensions to MRJob. It's based in Python, and yeah, all those things can be pulled in very easily, and it's pretty flexible.
I'm sorry, I don't see hands. I only see tweets.
I saw a hand down here.
Okay, we'll take it.
I don't know of any benchmarks, but
are there any benchmarks for specifically for running MRJob versus something else?
Mahout.
Okay.
Yeah, and Mahout is going to be much faster. Java is going.
So are you saying that Mahout's faster, but MRJob might be easier? Is that what you're saying?
Yeah, absolutely, totally easy.
Does that help answer your question? We're going to answer every question here.
There's an order of magnitude.
If I can, yes. Okay, hold on one second. Hold on. Just as a, okay, we'll hold off on this question, but I do have a tweet. I do have a question. You guys are alive out there. I'm glad to hear that. Keep going. Now, the next question I wanted to ask is, how to get your data. Is that the one you wanted to talk about?
Let me first address this question by one comment.
Okay.
So there is a rather standard, benchmark, being developed by different people. One is from Yahoo Research, and it's being used mostly on the NoSQL area. So HBase versus the other, NoSQL area. So it's getting traction, and it's by scientists try to be, impartial fully. So you can look it up. So
well, before we go to the question on how do I get my data in. I want to also ask the question, what kind of data models lend themselves to this scenario when you're first getting started? Are they, we heard risk. I know lots of unstructured data, but are there specific categories of business or departments or industries that you see getting involved in this first? Okay.
From my experience, and that's probably one of the introduction statements, that it's really important to understand where Hadoop is different from databases to be successful, right? So you need to use the right tool at the right space. So what really Hadoop is successful right now, it's one of them, or there are more, maybe 10 of them, but the most successful is session analysis, so user behavior analysis, because it's very good at sorting, very good at sequencing the events. And that's as far as I know what most of the companies are using right now, even though there are other applications in fraud detection and in other areas as well.
Okay. Other industries or vertical like department, where are you seeing the most beginners or usage?
Obviously, advertising, targeting biotechnology, and there's got a few friends working on this project. To add to the non-SQL, this is more transactional. If you want to do query against Cassandra, HBase, which are dynamic, multi-column orders, so it's pretty difficult. So you have to understand your. Yeah, I'm sorry. You have to understand your data model, and in this part, it's no different than if you use Oracle or a relational database. You still have to understand the kind of data and adjust the kind of storage which fits your model.
Now, just to kind of dig at these questions a little bit, when you talk about session analysis, to me, that looks like a very structured list of data. So it's not necessarily that you have unstructured data, right? Absolutely. Which I think is sometimes a perception. You know, we think of it as like a big data, unstructured scenario, but it's also maybe the fact that you want to use a commodity system, perhaps, or you want to be able to scale based on. You don't want to have a big honking, mainframe server that's really expensive. You want to be able to only use what you need so that other folks can release and use up the resources. Is that also correct?
Oh yeah, it is all about key value.
That's absolutely correct. I'm just saying from my experience that the most successful implementation I've seen is user analysis, but definitely Hadoop is very successful with non-structured, semi-structured data. The only problem is these are usually jobs which are not Hadoop specifically was designed for, because they usually take a lot of memory and you need to tweak the parameters for them to be optimized.
Got
you
it.
might even create your own data mart for these specific jobs.
Okay, we have, we'll let you go ahead, James, but then we have a comment from the audience.
Just a quick comment. I guess a lot of this distributed computing is really useful for doing all sorts of data analysis. So if you have a graph data, so think about, say, Facebook, where you have a big social graph, or think of the web, where you have a link graph from page to page, and you want to do some sort of analysis on say, the graphs, or sorry, the documents, and you want to see how important a document, say, compute page rank, for example. Well, you can do this very easily in a Hadoop type cluster, and previously, if you had to work on, say, 50 billion pages, that was a major headache. Today, it's much more, it's much easier. And so companies typically use this quite a bit for distributed algorithms.
Okay, and we had a comment from down here.
If I may, my name is Miguel Barrera, and I work with Greg in Cache Edge. And part of the problems that we have, or I would like to describe 2 or 3 specific problems that we have and see if Hadoop would be a feasible solution for this. One is profile matching, which is identity matching against large databases that we have collected historically to see if accounts match, profiles match, and identity, personal information match. That's one. The second one is predictive modeling using historical information, which usually computes averages, right? Standard deviations, sequencing, and processing of signals. And the third one is, okay, we're going to be doing scoring real time, which is similar to the problem that you have in advertising. You have a behavior that is coming in, and you have milliseconds of response time. So the question is, can we use Hadoop and leverage the infrastructure to address these problems? Would that be the right solution? Finally, just to put it, all of this is private information. I cannot load it to the cloud. I cannot pass personal information to the cloud. So it has to be a proprietary system that will be distributed computing in a closed network. So that's the framework. Thanks.
You log into Bank of America, transfer money to your E-Trade account. You want to keep it private.
Okay, and they were profile matching. There was also like a real time. That was number 3. Was like real time with data, like advertising. What was the second one?
Feature extraction, which is averages and predictive modeling.
Okay.
Clusters is a great example, right? Money laundering happens in direct flowcharts.
Okay.
Yeah,
You've got the mic, so Mike always gets to go first, but then we'll go to James, and then we'll go to Alex.
As far as batch computing, the sky is the limit. I mean, there's a group of researchers at Google that have promised like a theorem, essentially. Their theoretician, Muthu Krishnan, and his group, that you can do anything that you can do on another parallel architecture. So that's going to be pretty sweeping. And then it's always a problem how theory maps to practice, but it's going to be very encouraging. They haven't put it out yet, but instead of the real-time side, that Hadoop is not optimized for latency. So, I had some, I'm writing a R package for MapReduce, and there were some examples, and I was using a toy data size like of 1,000 records. And people say, well, it takes 12 minutes to do 1,000 records. Are you crazy? But then we went up to 100,000. It would take in 13 minutes, So it's really not optimized for that, and there's an HBase for that, still in the Hadoop family, but you can do MapReduce, right? So you can look at how Facebook is doing their analytics, real-time analytics. And that real-time, is it 2 seconds, 2 minutes? It's like a little fuzzy, but you have some hard requirement. And the data, if it is beyond this time, it's useless, essentially. That's what real-time is. And so they have, several talks out about how they did it, but not Hadoop MapReduce. That's batch computing. It's great for that, but there's a minimum wait, even if you do on one record. That.
Hey, before we hand the mic to James, Doug, you guys do a lot of pretty big stuff in real time. So
so my comment is the first thing people tell you when you're selecting a NoSQL data store is figure out what your queries are. So to me, that's code for make sure what you know what your application is. So one example is a canonical test case for an application is if I need to do a browser, with a browser, I need to browse all my data. So that's a good way to either look at a full table scan so in that case, Hadoop may not be your best fit, right? Maybe you go to CouchDB or whatever, right? There are different NoSQL alternatives out there that are optimized for specific type of applications. And so as the panels discussed, there are other frameworks that are good for computations, right? And computations imply a different type of architecture. So if your data is already in a Hadoop store, then you're stuck, right? You got to deal with Hadoop. But if you have that choice and you have some flexibility, a lot of times Hadoop isn't necessarily the best product for your application. They're all different. And something with feature extraction is a very different problem than if I need to run a model over 8 hours and I need to be able to optimize that 8 hours to 4 hours for production, right? So that's one thing. And the other thing that we found is that we have different silos inside of our company, meaning that everybody's got a different requirement. Like one guy that is responsible for email search for SOX compliance has their own NoSQL database copy of, I don't know, XX terabytes, but it's a very limited user base. They're all different is my point, and you can form the little canonical test cases for each one. And don't be shoved into this argument that says, I'm going to do what somebody tells me. Like run your own experiments and figure that out yourself, because then you'll be wiser in your next iteration anyway, and you won't fall into that trap.
Just building on that a little bit, for me, a lot of the work I do for my clients, it involves, first of all, understanding the problem and the needs of the client, and then there's a whole cycle of data engineering and then feature engineering. And finally, there's machine learning somewhere. And all of those things can happen in a kind of offline manner, and they do. For lots of companies. And so you warehouse your data, you derive features, you do time series analysis, potentially build features like that. Then maybe you start to do machine learning and evaluations and so on. And then to deploy, really, Hadoop is not a real-time environment for deployment. Generally, you're going to have to build a custom-built deployment platform. And again, that probably will be distributed over many machines, but you won't be doing this in Hadoop. What you will be doing in Hadoop is potentially aggregating data in the background and making that available as features to your machine learned models for scoring your clients in this case. I think it's a very common practice, and it works very well.
Okay, anybody else want to try to address those three topics or challenges?
Very quickly in terms of prediction. Yeah, we're going back. Yeah, it's about creating a model to be fast in real time. Hadoop is about creating a model. It's not to serve data in real time. Okay? So you can use Hadoop to create a model which is fairly precise and very, very fast. For instance, we do natural language processing. You cannot process content, a website and content in real time. You have to be 20, 30 milliseconds. But you can create a model that can be then dumped into, tuned and dumped into production. You can process. So this Hadoop for that is machine learning is a good example.
Yeah, I don't think we have enough time to discuss all aspects of that, but the real-time aspect is really interesting. And the problem is that most of it is in the research. I don't know if you know a Spark system, which was developed at Berkeley, and there are a lot of papers in this regard. And I actually expect a lot of work to be done in the next 1 or 2 years, and I actually expect data mining to move to HBase pretty soon. And then real-time aspect will be solved. And it's not even the limit. I think the glass is 99% full, as we like heard from the advertising talk today. For example, at Google, I know there are some in-memory systems which do some data mining or respond to queries. And we don't have open source analog at the moment, and it will be coming.
So this is real-time is basically the next frontier. Google is ahead with some of the internal systems. Facebook with messaging has made a headway on that side. A typical scenario is that you have the Hadoop system. On top, you have a something like HBase, some NoSQL, so that you can message pass or do streaming on top of that. Overall, by addressing the previous question, I would like to add log processing, which is one of the success stories with Hadoop. Besides no structured or semi-structured data, spam, web mining and such. But only a subset of data mining algorithms would lend itself to themselves to MapReduce framework, which it's basically go in with OpenEye. That's the bottom line.
Okay, we're going to pause right now for station identification. And while we're doing so, I just real quick, I want to hand this list out. If you're interested, we are going to be setting up something called the Silicon Valley Cloud Center, which is a 7,500 square foot building that I get to use for free, and it has a data center. And if you guys are interested in working on projects like this as part of the community, some of the panelists, namely Amir and I, are going to be setting up environments where you can actually come and work on stuff. And we'll have training there, of course, too. But the Cloud Center itself will be free, and hopefully Greg and some others were talking about maybe doing some other types of more specific camps there. If you're interested in that, please go ahead and sign this, and you'll just put your email address down, and we'll tell you when our first events are. Okay, I'm going to go ahead and move on to the. Okay, that's it for the break. We're back now from our station identification, and we'll move on to the next question. Now, we had a question from the audience. I want to make sure that we get that questions asked and answered. Oh, thank you, Greg. The question was, is there any tool to stream data from Oracle to Hadoop in near real time? And that, I think, follows up on the answer that you just gave a moment ago.
Yeah, I let you speak about Scoop and other Cloudera projects.
Make sure to speak close.
So,
if you can't hear yourself, by the way, you're speaking. It's not close enough.
Okay, there are two products from Cloudera that I let my colleague here speak to. There have been some other attempts, at least 4 of them, that people need real-time processing, so they stream data inside. And the same question applies to having it outside. So there is a proxy on top of HDFS that helps you get the data, incrementally. There are other projects called U-Haul, which may, become open source, built internally at Yahoo. Hopefully, we can have that as well. But outside, I let my colleagues speak about Cloudera solutions.
I think you already told the audience that we developed 2 tools internally. Actually, both of them are in open source right now, Scoop and Scoop Flume, right? So.
But then your data in Hadoop that doesn't work very well real time. So, what is the point? So, now Scoop is fantastic. It's very scalable, and we tried to solve the problem internally at Hi-Fi. We tried 3 times. We couldn't really nail it like those guys. Just it seems like a stupid problem just to copy stuff from a database to it's not. When you have in Flume and when you have 400 web servers churning day and night, it becomes a difficult problem. So, but then when that is in Hadoop, then it's a batch processing. So what's the point of bringing the data at incredible speed if then it takes 15 minutes to get the results out? So you should work at these other projects I want to mention too, but he started listing them, and like S4 from Yahoo and Storm from Twitter was Backtype, and there's a whole family. It's not clear who's going to win and who's going to be really, have a huge community, but those are meant to do that kind of stuff, really stream processing, 2 seconds to get through the data, move on to the next thing.
To follow up on that, I think what you said was, it sounds like a dumb thing to do, but it's actually an important thing to try to be able to solve. Is that what you said?
Just bring it into the right system. If you really want real-time performance, then you need to look at this. It's the next frontier. These systems are a little half-baked. It's really fresh stuff. I don't know them very well, and they're obviously mature, but they're meant to do that. So I'd rather help those dedicated projects that do the streaming the real time well, rather than trying to force real time on MapReduce that doesn't really, you're gonna face hurdles that you won't be able to.
Is what you're talking about is Twitter an example of maybe what you might do, where you obviously need to take data in and then send data out, but maybe there's some sort of processing that needs to be done in the meantime, and they're trying to get it done as soon as possible. So some sort of infrastructure like this might be useful.
Cafe for Google, when they were trying to make their search as fresh as possible. There's many examples where data is good, but fresher data is better. So you can run a batch job. LinkedIn still. They do everything in batches. They make their batches short. I think I heard somebody from Yahoo saying that they were crashing their personalization of